Hey everybody, Timothy Karambat, creator and founder of AnythingLLM, and today I was going to do a different style video. Now, usually the videos I do are all about AnythingLLM or just like AI tech in general. And I'll like run some models, do some tests, highlight a cool feature that we built, something like that. Today, I actually want to do a little bit of a different review and just see how that goes, honestly, because why not change it up? So for my first video of this kind of format, we're going to start off with a bang. I recently got access to NVIDIA DGX Spark. It's right here. So I've had access to this for about a week and a half now, and I've actually been using it as my daily driver. So, my day-to-day job, right, is making AnythingLLM better for you. Doing that, I usually do it on a MacBook, but I have a whole bunch of other computers so I can test it on everything. And now I have a DGX Spark, which is actually running Ubuntu or DGX OS, which is a version of Ubuntu 24. So it's very familiar. It feels a lot like Mac. If you've used Ubuntu before, that someone's going to get mad about that, I'm sure. But I want to jump into a review of this. No BS. We're just going to get to it. So as I said, for the last week and a half or so, I've been actually using this as my daily driver. Personally, I'm impressed. It's a lot of fun. And it's just really cool to use because even with someone who has like an NVIDIA GeForce RTX 5090, this is still cool. It's supplemental to that. It's not a replacement. I'm going to get into that more in the video, but let's talk about kind of unboxing right now. So when you get this thing, it comes in a pretty hefty box and you just slide it on up. All the chargers and stuff are on the bottom, but what you get, something that looks like this. So immediately, you're going to want to pick this thing up. And you're going to notice that while it feels very sturdy, it is actually pretty light. It's 1.2 kg, or if you're in freedom units, that's about a shave over 2.5 pounds. And then dimensionally, it is 150 by 150 by 50 millimeters, which is about 6 by 6 by 2, again, in freedom units. The first thing that I noticed about this was the color. It might be hard to pick up on camera, and I'm not sure if that's even focusing, but it is this nice gold color that there's two immediate things that come to mind from my childhood. One was the gold Game Boy Color, and the other was for, I think it was the Nintendo 64 Zelda Ocarina of Time cartridge, and it was about the same kind of color. There's no like sparkle in it or anything like that, but it's just such a cool color. So the first time that I think this got mentioned was actually at CES of this year, where they talked about something called Project Digit. This is that. They renamed it, and it's now called the DGX Spark. And you're obviously wondering, because it is NVIDIA, what is in this thing? This is not a hardware review channel, so I'm just going to kind of give you the high-level stuff. So in here is the NVIDIA GB10 Grace Blackwell Superchip. This is a unified memory kind of system here, and there is 128 gigabytes of LPDDR5X memory in here. This particular model has 4 terabytes of storage, which is plenty. And of course, you have a 20-core ARM-based CPU, which is really great because of power draw concerns. This thing sips power. I wish I had more metrics on that. I didn't have an ammeter, but it is ARM-based, and I do know it is drawing less power from the stats that I can collect. Of that 128 gigabytes of unified memory, I believe 96 of it can be allocated specifically just to the VRAM, although I don't know if that can be unlocked. I'm sure someone will find a way. And when it comes to memory bandwidth, it's 273 gigabytes per second. This actually allows you to run models up to 200B, depending on the quantization, obviously. And then what you really get is about 1 petaflop of FP4 AI performance. If you aren't an AI model nerd, you don't care what that means. But if you're an AI model nerd, you probably care about what this is. And as I mentioned before, it comes with Ubuntu 24 LTS with this specialized kind of just a lot of preloaded software, the stuff that you need to build and run AI tools or run fine-tuning jobs. A lot of the default stuff's already in here. So you've got the NVIDIA Container Toolkit, you've got NVIDIA SMI, like basically any tool that you would need. All of that is just pre-installed, which is so nice because you don't have to install it at all. So what are we going to showcase today with this computer that was built from the ground up to build and run AI tools like AnythingLLM, but also for fine-tuning and all these other things. Today, specifically, is first, I'm going to show you around the OS. It's very familiar if you've used Ubuntu. We're going to actually use AnythingLLM and some other tools that can run natively on this hardware to be able to just show some models running and benchmark them and just get an experience and also get an idea of, obviously, tokens per second. And then also, I would like to show a pretty realistic fine-tuning example as well, where we're going to probably use mid-size model like Gemma 3 4B to make a fine-tune for some specific use case. There are two ways to run this. When you get the manual for your DGX Spark, it's going to actually give you two configs in here. So you can use it basically as a desktop. You plug in an HDMI cable and whatever other your peripherals are, and you just use it like a computer. It has a whole setup process. If you've used Ubuntu, it's pretty much exactly like that. But then there's another mode, which I think is also interesting, where you can actually use it as a networked device. So you could have this centralized in your office or in your house and use it as a dedicated compute machine for AI workloads, which is the next thing that I would like to get to, is specifically AI workloads. There have been a lot of criticisms, or I don't even want to say a lot, and I also don't even want to call it criticisms. It's just people, I guess, talking about this on Reddit, saying all of these things like it's supposed to replace a Mac Mini. This is not that. This is an additional compute resource that you can just use to free up whatever you're using already. So like I have a GPU on my computer, I can continue to use that and then offload work to this dedicated device for that. People have HomeLabs with Mac Minis strung together. This is not a Mac Mini personal computer replacement, but it is for the HomeLab use case where people have been chaining them together. In fact, actually, you can stack two of these on top of each other, and there's a big connection port in the back that you can chain them together. And so you can actually get double the output, which is really cool. You can run really large models at actually a good quant. And of course, because this is the DGX kind of OS, if you do, for whatever reason, have access to a $350,000 H100 server, the code you write on this for your apps or whatever jobs you're running, you can actually just use on a server. As you can tell from the background of my video, I do not have one of those servers. If you're building a HomeLab dedicated for AI workloads, which I see all the time on r/local Ollama, this is a reasonable device. Now, it depends on what your price range is, but I've seen some really expensive HomeLab setups, and I think that this is actually in a reasonable price range. And on that note, I do want to say that the one I have, which is very clearly labeled here, is early access. So the stuff that I'm getting, the results that I'm getting could be better, could be worse. They might just be different, but just something to highlight there. And I just want to take a quick little sidebar. For those of you who don't know, my background's actually mechanical engineering. Before I got into the whole founder software thing, I was a mechanical engineer. And this thing has just a couple interesting design highlights, and I'm going to actually pull in the zoom here so we can go over these kind of details. So looking at the front of the device, you can notice that, there's a little bit of these polished kind of areas right here that also expose some vents. But one thing you may have noticed is this very interesting material choice on the front of the device. This looks like some kind of like open cell metal foam, probably aluminum, but this is actually an air intake. And it's just a really interesting metal choice and just design decision in general. I personally really like it. It's also not very rough to the touch, like it doesn't have any kind of like burrs or snags. So you can like handle this pretty reasonably. And I imagine stacking two of them would look really cool. The bottom of the device is really nothing that you wouldn't expect. So of course you've got your kind of grip here to keep it from sliding around on surfaces, as well as an additional air intake. And on the back, we get that same open cell metal foam finish again, but this is also exhaust as well. You can feel kind of air coming out of there. You have your power button, which my first complaint about this device is it has no on light. You have no idea if this thing is running. So what I've been doing is putting my hand in the front of the front vent to feel for any kind of suction, or just putting my ear up to the device and listening for the kind of whirring sound that you can hear. You have technically 3 USB-C ports. The first one is for your power, and then you have 3 additional. I personally have no USB-C peripherals, so I had to buy some converters off Amazon for about $6. And then you've got your standard HDMI port, and then you have your Ethernet port. This comes with Wi-Fi and Bluetooth. These are the specialized ports that can be used to stack two DGXs together. Now for the next part of this video, we're going to get into the software side of things. We're going to run GPT-OSS 120B, yes, the big one. And then of course, we're going to jump into that simple fine-tuning use case just to get an idea on times for that.
So when you first boot up your DGX, you're going to be greeted with a screen that probably looks a lot like this. And you'll notice it looks and feels, because it is, Ubuntu. And so if you're familiar with Ubuntu, you're already familiar with this, except it comes preloaded with some additional software, as well as tools. And that's the real nice part. So for example, you've got your regular stuff like your system monitor, calendar, you've got LibreOffice, that kind of stuff. You've also got this DGX dashboard. You also have the NVIDIA AI Workbench, which is really nice because if you do a lot of Jupyter Notebook stuff or like data science or even like training models, the NVIDIA AI Workbench is a great tool for that. It just comes with your very kind of like basic software. VLC is already included. And of course, it comes with, some cool backgrounds. So this entire UI should feel very familiar. Some of the tools that are very useful that it comes with is like NVCC is already installed. NVIDIA SMI already works. And you can see the driver version that we're on. We're on that GB10 supported CUDA version of 13. And then, of course, if you are interested in your GPU stats, NVTop is also already present. And so there's just a lot that you can see and do in here just by default without having to set up any additional software. I think people know that setting up all of the CUDA libraries and the toolkits and the stuff that you need is always just another step to take. But for the next part of this video, we're actually going to play around with some actual models. So I already have Ollama installed. I'm on 12.5, and I actually already have some models installed. I have GPT-OSS 120B installed right now. Of course, you can always just, do Ollama run GPT-OSS 120B. And then just send you need to send a simple message and you get some tokens back, but sometimes you'll want a little bit more verbosity. So you can say, hello again, and maybe we can get some stats this time. You can see we're sitting at around the 30 tokens per second rate. And chatting with a model through a CLI is, it's fun. It's useful, sure. But what most people do is they have a tool like AnythingLLM, where you can set up workspaces, you can have access to agent tools, you can build your own tools in a flow builder, you can write your own code, use MCPs, search the web, generate charts. You can do a lot just in AnythingLLM. And of course, we're going to do all of this by just hooking up to Ollama that's already running and using that GPT-OSS 120B. AnythingLLM comes with its own internal Ollama if you don't have Ollama installed on your system, but you get the same experience no matter what. And so I think one of the easiest things to show is there's this website that has a bunch of CSV files that are just good, sample CSV files to kind of show proof of concept. CSVs are probably the most popular format for people to use AnythingLLMs with, right alongside PDFs, who want these models to help them be productive. And so there's a fun one in here called De Niro CSV, which has all of the Rotten Tomato ratings of Robert De Niro. There's 87 records in here, so it probably isn't all of his movies, but it's definitely enough of them. So what we can do is, in AnythingLLM, we can just simply open up the downloads folder, drag and drop that in, and just ask it. And just ask GPT-OSS 120B to analyze this data set. And if you've used GPT-OSS at all, you'll know that it loves tables. And so what we're going to see here is GPT-OSS just work through all the data here, not formatting it in a way that makes sense, asking follow-up questions. These kind of things are all part of the model's capabilities. So we're going to let that work. And so that is the analysis that it gave us. It gave us a bunch of quick takeaways. We could ask follow-up questions, but I really don't know what else I would follow up with. I mean, there's even analysis as to why school scores may have dropped and why movies were poorly received. I mean, obviously, I think everybody here knows that Taxi Driver and Goodfellas are amazing, and we definitely don't talk about these two movies. And also, the more importantly, we are still sitting at that 30 tokens a second rating. So we're getting consistent performance across large outputs. And of course, inside of AnythingLLM, we're able to do a lot more here where we can modify the system prompt. We even have prompt variables, or you can add kind of dynamic data. There's a whole bunch you can do in this tool, and having a really capable model that can also run incredibly fast to do actual productive work is really, really nice. And you can imagine just putting this somewhere in your office or somewhere in your home and having it be your centralized inference service is really a reality with a device like this. If you are interested in AnythingLLM Desktop and what I showed you, you can always download it for free on your device today, as well as we do have an open source repo here that is available and MIT licensed. But this video is not about AnythingLLM. It's about the DGX Spark. So in the next part of the video, I'm going to talk about fine-tuning your own custom model on this hardware. I do want to preface this part of the video that not only is this the nerdiest part of the video, because it is going to involve code, we're going to be in a Jupyter notebook, but also this is really where the DGX Sparks also shows its unique capabilities, because this is the stuff that it was built for. What we're going to do is I have a Jupyter notebook already up, but first I want to talk about Unsloth. Unsloth are the people who made this book. Unsloth is an open source project. You can find them on GitHub. They'll be linked in the description. And they have built a custom training framework and even kernels for a bunch of different types of GPUs, but just being able to tune models in a more memory efficient way. Even though we are on a DGX Spark, which has a lot of resources available, Unsloth has even made it possible to tune models on even lower end hardware. But since we have really good hardware, we're going to actually use a mid-sized model. So the model we're going to be working with today is actually going to be Gemma 3 4B instruction model. This is going to be a use case fine tune where we are going to do something with this model to make it better for what we specifically need. Just going over the high level of what this whole document is supposed to be doing for us is we are going to go through this step by step, and I will share a link to this exact file so you can run this fine tuning as well. But the detail that really kind of matters here is the data set. And so there is a data set here of basically support tickets, IT support tickets, where a user is complaining about something or a bug has occurred or there was an issue, and then there is a recommendation to resolve this. Now, this particular data set is actually, I'd say, pretty generic, right? Maybe there's specific verbiage and processes that are outlined in this data set, but in real life, you probably have some kind of use case or repetitive input-output framework or standard operating procedure that just generally models don't capture. And the only alternative to that is to pollute them with a lot of context that then gives you less ability to put more tokens to the output. And then when you allow fine tuning for these models, you can have a model inherently just be smarter about a specific domain. This data set is just, a very basic data set. I believe there are 500 something examples in this. You don't actually even need that much data. Here's one with a lot more, with 100,000, but this is more of a general QA, kind of like ChatGPT answers, like explain a ternary operator, develop a lesson plan. Like these are questions that every model's base tuning is pretty decent with, I'd say very decent with nowadays. So training on this data set is not really going to move the needle for us, or give us a different output than what we would expect. To get started, I already have this Jupyter notebook running, and I'm running it obviously on this DGX. So the first thing to do is to actually load the model in. And at the end of this, actually, we're even going to have the opportunity to output this file as a GGUF. So you can then export this file, load it into anywhere you can run a GGUF. You can now run this fine-tuned model. We're not going to do that in this video, but I am going to show you the process and how it is legitimately one line of code. And now that the model is loaded, we can just keep going through these steps. And then we're going to load this data set. And then the most important part of a data set is formatting that data properly. So I've already gone ahead and wrote a little bit of code that it took to do that. Here's an example of an input snippet, which is where the user and the agent have a discussion. And then what we want from our output is an analysis. What we want is to see this kind of output where we begin with an analysis and then have a recommendation. And maybe in our internal system where this model runs, that means something. Those headers mean something. And this is just the formatted output from the text conversation. So now the first thing is let's get the trainer ready. So the trainer is just basically taking our data set, tokenizing it, and getting us ready. And then we're going to tell our training process that we're only training on the responses because that's the part of the data we actually care about. And then let's just make sure that things look all right, which I've already gone through this. These things look okay. But the main thing is first, what does Gemma 3 even respond as to a basic scenario? And you'll see that it kind of gives this generic answer of saying, oh, that's good information. Let's narrow it down, uninstall the current version. And it's talking about Zoom, which, by the way, this scenario sample does not say anything to do with Zoom. So this is just the model hallucinating, essentially. And so you can see that, it doesn't really give an answer that is specific to our output, especially with no analysis block. So let's train the model. Now, this can take some time, but normally you can actually use a service by Google called HomeLab. And HomeLab allows you to run these kind of scripts. Actually, you could probably run this script on NVIDIA T4 GPUs. I can tell you from experience, because I've done this already on the cloud, that this particular training job, the exact code that I'm running here, takes about 17 minutes to run on average. I've run it about 4 or 5 times just to get a good idea. So I'm going to let this run and we'll see what the stats are to train on the NVIDIA DGX Spark. Okay. And you can now see that all 60 of our training steps for one epoch have run. That was on 504 pretty chunky samples. And of course, I cut through the video a little bit just to save time. But the one thing you can't cut is the actual time that it took. So as I said, on an NVIDIA T4 in HomeLab, this would take about 17 minutes. But here it only took 4.3 minutes, which is awesome. That's an incredible time save. And also it lets us iterate much faster, which is great because when it comes to fine tuning, you really don't know what you're going to get until you do it. And so iteration speed is extremely important for anyone who's fine tuned. But now we should be able to see, do we get the output we expect? So I took the same scenario that we had in the previous block where we were experiencing a black screen, and we now get the model giving us the actual kind of output that we want. We have an analysis block and a recommendation. Now, this specific format is not only from our data set, but so is the content. And I think that is the important part, because a lot of people would say, oh, well, why don't you just have a system prompt that just says break it out like this? It's not only the format sometimes it is the output. And most times it's actually both. For anyone who's fine-tuned models, that's a pretty obvious thing. But, obviously there's more than one scenario. And so we can do this again on a different scenario that we haven't tested on before. And you can see that we still get that same format. We still get that output. Now, of course, if we don't have direct output that we were trained on, then of course the model is going to try to answer the question anyway, but still within its new domain expertise and while keeping that format. So now we have a model that works the way we want. We took Gemma 3 4B, which is a great model for its base and gives an okay answer, right? When we use it totally untrained, just straight from Google. But when we apply just this 500 sample data set, we're able to get the answers the way we want. And now we have our own version of Gemma 3. Now, of course, you're going to want to take that and put it different places. Obviously, this specific model is not very useful if it's stuck in this notebook. And so to do this, you can just do model, save pre-trained GGUF. You can do it at F16, Q4, Q8, Q5, or a whole bunch at the same time if you know that this is a good model, but you're going to want to offer it at different quality levels. Great. You can do that. You can save all of those to a GGUF completely compiled and then take that and put it in your software of choice. And that software of choice could very well be AnythingLLM. We have a way to import GGUFs if you want. That is the kind of software overview and demo for the DGX and for this fine-tuning use case.
It is definitely worth saying, though, that this is the version that NVIDIA will be selling off of their website. And from what I do understand is that there are other OEMs out there who are going to be utilizing this GB10 chipset, but in their own OEM form factor. But just know that this is not the only way that this device and its hardware may be presented to you if you're interested in them. And I'm sure, like we see with graphics cards, there's different form factors and packages and all of that stuff. So hopefully this demo of showcasing the kind of early access NVIDIA DGX Spark was useful, gave you some insight into maybe some practical uses. I mean, we did run AnythingLLM just to get some benchmarks on some models. We did do some fine tuning just to showcase that there are some performance improvements there. It's just a nice dedicated device. And I think what I'm going to do personally with this device is I'm actually going to set it up probably at my house first, but then maybe move it into an office, just to have a dedicated, centralized, but still local kind of LAN-based inference service that I can just use for whatever it is that I want to use. Most tools allow you to just slap in a endpoint that you can use. Like if you're using something like a continue.dev or a void editor or some other, or even like one of the Claude codes out there that allow you to put your own inference URLs or run your own coding models. Probably just load this up with a coding model, honestly, and just use this and save some money on Cursor or whatever it is you might be using. But that's it for now. If you're interested in AnythingLLM, we're an open source project. You can star us on GitHub. If you want to use a desktop app, it's free to use and free to download. If all you have is a phone, we actually now have a phone app, AnythingLLM Mobile for Android, and you can download it and run small language models and still get utility out of them on device. And actually, if you do have something like this, you can actually hook your phone up to use this endpoint instead and get a really powerful experience just on mobile. So whatever you want to do, I think this is a good fit, but thanks for watching. Bye.